Find the area of this triangle. How does it work? Well, Aaron's formula says that we do it in 2 steps. First step, step 1, is to find a half of the perimeter of the triangle. So the perimeter is the distance around the triangle. So we can do this. And then, when we simplify this, to make our numbers easier, let's use 18 so we don't have too many fractions. Let's use 18. So this would make it a lot easier. 10 plus 20 is 30 and 18 is 48. So a half of 48 is 24. So we just discovered that our perimeter is 48, and therefore our half the perimeter is going to be 24. And Heron's formula says that the area is equal to the square root of this number 24 times 24 minus 20 times 24 minus 18 times 24 minus the third side, which is 10. And if we simplify this, it gives us the area of the triangle. So we go, and this gives us 24 times 24 take away 20 is 4. 24 take away 18 is 6. 24 take away 10 is 14. And all we have to do is to take our calculator and find the square root of this product. So we go, it's the square root of 24 times 24 times 14. And that works out to be 89.7, 89 point, approximately 89.8 squared. So this is one of the last things that we covered from our last session. Again, Aaron's formula says that if you're given the 3 sides of a triangle that is not a right triangle, just given 3 sides, no angle at all, then we can find the area by finding a half the perimeter. A half of 10 plus 20 plus 18 gives you 24. And then we use this formula, the square root of 24 times the difference of 24 and each side, the product. So we get 24 times 4 times 6 times 14. When we multiply those and find the square root, that is the answer. Now, if we were asked to find one of these angles, then the law of cosines is going to be the one that we will use in order to find the length of, or find one of the angles that is of the 3 that are there. So let's go right into that immediately. As I told you last session, after today, we're going to pull back a little bit and cover some simpler topics, and then we'll build back up again. But starting next session, we'll be completing Introduction to Coordinate Geometry, equations of lines, parallel lines, parabolas, etc., circles, etc. But for this week, we're going to wrap this up. The law of cosines is where we're going to go. And we have some very interesting practice to do with that. According to the principle or the law of cosine, we know that our naming convention for triangles is if you have this as your angle, then across from it is your side. If you have this as your angle, the lowercase is the length of your side. And if this is your angle, and this is your side. According to the law of cosines, it says that a squared is equal to b squared plus c squared minus 2bc cosine of A. So notice we start with side A, we end with angle A. And the same principle applies if we used another side. For example, b squared is equal to, this part will always be the other two sides. And then we'll always end up with cosine angle B. So it's going to be a squared plus c squared minus 2ac cosine B. And finally, if we're talking about starting with side C, then we could write c squared. The principle says that this part here will be the other two sides, and we end with cosine of what we start with. So it will be cosine of angle C. So there we go. It's a squared plus b squared minus 2bc cosine, sorry, not bc, 2ab cosine of angle C. So those are the three representations of the law of cosine. Now, you might see in a book where they take one of these and solve to get the cosine of an angle by itself and everything else over here. But just knowing one version of it is enough, and you can manipulate it to get whatever you need. Okay? So now that you have this, the law of cosines, we need to look at an example to see how it works. Here we go. I will also point out some very common mistakes that people make. So if this is A, and let's use, say, 20, let's use 15, and let's use 12. I guess it looks more like, yeah, 12 is fine. Okay, suppose we need to find, say, angle A. Suppose we need to find angle A. How do we go about doing that? Well, first of all, yes, suppose we need to find angle A. How do we do that? We could do that, or let's do the easier one first. Let's say we did not know this. We did not know that, and this was, say, 45 degrees. And they say to you, what is little a? Let's do that first, because this is easier than finding the angle. So we'll find this first, and then we transition over to finding the angle. Okay, according to the law of cosines, it says a squared is equal to, well, let's quote the formula, and then we substitute the numbers. So it's going to be b squared plus c squared minus 2bc cosine of angle A. So in this case, it's going to be b squared is 20 squared plus c squared, this is c, it's going to be 12 squared minus 2 times b is 20, c is 12, cosine. And A, of course, angle A is 45 degrees. Let's do the numbers. 20 squared is 400. 12 squared is 144. And this is going to be minus 2 12 24. So that's going to be 0, 8, 480 cosine 45. So 400 plus 144 is 544 minus 480 cosine 45 degrees. Let me point out a very, very common mistake. Many students will be tempted to do the subtraction here, but you can't do that. It's illegal. If you did that, it's incorrect, because 480 cosine 45 means 480 times. That's a multiplication, and according to the order of operations, multiplication has a higher priority than subtraction. So you have to do this multiplication first, and then whatever you get, you subtract it from 544. So common mistake is to say 544 take away 480, and that would give you 64. And that would be incorrect. So they would write 64 cosine 45, and they would end up with the wrong answer. You don't want to do that, okay? So we go, it's going to be 544 minus, now you take 480 and multiply it times cosine 45, and that will give you a number. So that is 480 times cosine 45 degrees. And that gives me 339, approximately 339.41. Okay, when you do the subtraction, what do we get? We get 204.59, approximately 204.59. So therefore, side A has to be the square root of this. So A is going to be equal to the square root. Notice this is A squared. So A has to be the square root. So A is going to be the square root of 204.59, which is approximately, and now we take square root of 204.59. And that's approximately 14.3. So think about it. This is 45 degrees. So therefore, it has to be a small angle compared to angle B. Angle side B is 20. So therefore, this angle is going to be a bigger angle than 45. Between angle B and angle C, they should total 135 degrees. Okay? So there it is. Okay, let's try another one. Let's try another one. Okay, so here we go. Yeah, that's ugly. So let's go for 20, 15, and 13. And let's call this A, B, C. And we need to find angle C. According to this diagram, side C is the largest side. So therefore, angle C has to be the biggest side. Make sense? Angle C has to be bigger than angle B and angle A, because side C is bigger. It's the biggest of all the three sides. So here we go. According to the law of cosines, You start with 20. Since you're looking for side angle C, you start with 20. So you go 20 squared is equal to 15 squared plus 13 squared minus 2 times 15 times 13 cosine of angle C. Again, we start with this side, we end with this angle. Start with this side, you end with this angle. If we started with this side, A, then we'd have to end with cosine of angle A. If we started with the 13, we'd have to end with cosine of angle B. So that's the relationship. Okay, so now we have 400 equals to 15 squared is 225, 13 squared is 169, minus, this is going to be 30 times 13 is 0, 39 cosine C. Okay, add these two together, so we end up with 400 equal to 225 plus 169 gives me 394 minus 390 cosine C. Okay, so now we can subtract these because we have to do the multiplication. The 390 is connected to the cosine of C, so we have to get rid of this by subtracting this from both sides. Okay, when we subtract, we end up with 6 equal to negative 390 cosine of C. So therefore, to get cosine of C by itself, we divide by negative 390. So therefore, cosine of angle C is equal to negative 6 over 390. And therefore, angle C is equal to get rid of cosine, we do the inverse of cosine, which is cosine to the negative 1, or I did mention to you, it's also called arc cosine. That's ARC cosine. So we do cosine to the negative 1 of 6 of negative 6 over 390. And that's approximately, take the calculator, and we go. So, second cosine of negative 6 divided by 390, those parentheses, and we end up with 90.1, 90.888, or roughly call it 91 degrees. That's it. I knew it was going to be an angle bigger than 90 because it is negative. We will discuss that another day when we talk about which trig function is positive in which quadrant. That's a different conversation. We're not getting into that today. So look at what's at the board. Remember when we just started, we're doing A plus B equal to C. We're doing 2A plus 3A equal to 5A. Look at where we are today. Much more advanced. But we're adding skills to our toolbox. And there are more skills to come. But we're going to break it down and start with some simple things next week again, and then build back up. So this is the law of cosines. So let's look at some examples how we could use the law of cosines. Okay, here we go. So we are at C, and there are 3 boats. Boat A, boat B, and boat C. The distance from A to C is 200 kilometers. Let's make it shorter. Let's make it 100 kilometers. Distance from B to C is 400 kilometers. If the angle between A and B from C is 40 degrees, how far is A from? So again, 3 boats are at sea. A and C are 100 kilometers apart. C and B are 400 kilometers apart. And the angle between A and B from C is 40 degrees. How far is A from B? And I guarantee you that when doing the routes for planes in the traffic control towers, they're able to do those calculations to see the distance apart from 2 airplanes. Okay, so we'll call this little c. And according to the math, law of cosines, we say c squared is equal to 400 squared plus 100 squared minus 2 times 400 times 100 cosine of 40 degrees. And all we have to do is to solve that equation and problem finished. So this gives us 1600. We know that the unit is going to be in kilometers. We're working with kilometers, 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 kilometers. Okay? So we know that's what's going to happen. This is going to give us, because it's square, it's kilometers squared, kilometers squared. So when you do the square root of km squared, you get km plus 100. Okay, so this should have been 2 more zeros. Ha. Let me clean it up properly. 400 times 400 is going to be 16 with 4 zeros. This is number 1 with 4 zeros. And then minus 2 times this gives me 8 with 4 zeros. Cosine 40. Simplify, add this to this, gives me 17,000 minus 8,000 cosine 40. Eight thousand times cosine 40 is 1, 2, 3, 4. 1, 2, 3, 4. Okay. So this works out to be 170000. Take away 8,000 times cosine 40 equal. And that gives me the number 108,716. 108,716.44. So therefore, C has to be equal to the square root of 108,716.44, which is approximately equal to, so let's go, square root of 108,108,716,716.44, close parentheses, and the answer is 329.72. kilometers. So the distance from A to B is 329.72 kilometers. So that's it. There it is right there. So look at how we took the pieces, applied the law of cosine, and there it is. So what I'd like to do now is, now that we have established what the law of cosines represent, how it is used, I would like to recap some of the highlights of what we have done over the last 2 weeks. So let's see. So I'm going to do a quick recap. Okay. Remember, we said trigonometry has to do with the science of triangles. Okay? So trig is also an abbreviation used for trigonometry. Instead of writing out trigonometry or saying trigonometry, in math world we say trig. Okay. First, we talk about the ratios. In order for you to do the trig ratios, we have to have a right triangle. Okay? So if we have A, B, C, and this, if we're looking at angle C, then this is opposite, this is hypotenuse, and this is adjacent. And what we discovered was sine of angle C is going to be equal to opposite over hypotenuse, O over H. Cosine of angle C is going to be the adjacent over the hypotenuse. And finally, tangent of angle C is going to be equal to opposite over adjacent. And as a quick summary, we introduced a mnemonic that we can use to recall what the ratios are. And that mnemonic was SOH, CAH, TOA. Where this means sine is opposite over hypotenuse. It's SOHCAHTOR, SOHCAH with an adjective, SOHCAHTOR. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. SOHCAHTOR. A lot of people have used that for years to remember the different ratios. And then, of course, we also talked about the reciprocals. Sine of C, and we also talked about cosecant of angle C. So CSC, which is cosecant, C-O-S-E-C-A-N-T, cosecant. Is the reciprocal of sine of C, meaning it's 1 over sine. So therefore, that will be hypotenuse over opposite. And for cosine, we found out that secant secant of C is the reciprocal of cosine, which is H over A. And the reciprocal of tangent, we found out, was cut. Cotangent of angle C is going to be A over O. We also discussed that the opposite and the adjacent will depend on which angle we're doing. If we're talking about angle C, then this side is opposite. If we're talking about angle A, then this side will be the opposite and this will be the adjacent. The hypotenuse will always be the one across from the 90 degree. So that's what we do for the right triangle. If it's a 90-degree angle, we say it's a right triangle. And the only other thing I would like to mention is the area of a right triangle. Okay, so we talk about area. We came up with actually 3 different methods to find the area of a triangle, depending on how much information you have. Okay, so if you have a right triangle, or if you have a triangle that you can find the height and the base. If it's a right triangle, then these two are the legs. And therefore the area is equal to a half times the base times the height. So we could easily call this the base, and call this the vertical, the height. So if we're able to determine the height and we have the base, we know the base and we know the height, then the area is a half base times height. But it's not always as easy as that. In some cases also you might have something that looks like this, and you're able to drop a perpendicular like this. If you're able to do that, and you're able to find the H and know that the base is from here to here. If there was a way that you could calculate the height and you know this base, then you can also find the area of this. It's a half B times the H. But there are some cases where you do not have enough information to find the height or the base. When you don't have that amount of information, then this cannot work. You have to try and use something else. So a half base times height can only be used when we're able to calculate the base and the height. If we have those 2 pieces, yes, we can. Okay. Second method says that if you have if you know any 2 sides and the angle between, then you can find the area. It says here, area is equal to a half B times C sine. If you know these 2 sides and you know this angle, you can multiply a half times B times C times the sine of this angle. Similarly, if you know these 2 sides and this angle, then we can say area is equal to a half AC sine B. So if you have side, angle, side, SAS. You'll hear that expression later, side, angle, side. You have the side and the angle between the two sides. Side, angle, side. Then you can use this formula to find the area. So the last one will be A equal to, using these two sides and this angle, we have a half AB sine C. So for you to use this approach, half AB sine C, you must be able to determine two sides and the angle between the two sides. If you can't determine them, you're stuck. The third concept goes like this. Or the third method says that if you have any triangle and you know A, B, and C, any triangle and you know all three sides, then you can find the area by doing two steps. Do S equal to a half A plus B plus C, and then the area is going to be equal to the square root of S times S minus A times S minus B times S minus C. That's the third method. So if you have two sides, so if you have the three sides, and this is called Heron's formula. That's Heron's formula. Okay? And then the only other two principles I would like to rehearse with you, just as a recap, as we get to leave our introduction to trigonometry. We're going to leave for a while and then we'll come back later on. Principle that I would like to cover is called the Law of Sines. Just recapping the Law of Sines. It says that if you have any triangle, A, B, C, this would be B, this would be A, this would be little c. It says that there is a relationship between the ratio of a side and the sine of its corresponding angle. That ratio is equal for all side and angle corresponding. In other words, sine A over little a is the same as sine B over little b is also the same as sine angle C over little c. So if you knew, say for example, angle B and side B, and you have one other piece of information, you can find all the missing pieces. Similarly, if you're trying to find the length, you could just flip the fraction. A over sine A is the same as B over sine B is the same as C over sine C. So that's the law of sines. Very, very useful, extremely useful. And then, of course, the one that we did today, is called Law of Cosines. It says that if you're given a triangle A, B, C, then you could write, this gives you a method to find a missing side or a missing angle. So you could have a squared equal to b squared plus c squared minus 2 bc cosine a. And the pattern is whatever side you start with, that's the angle you finished with. If you start with side A, you finish with angle A. If you start with side B, then this is going to be A, this is going to be C, this is going to be AC, and this is going to be cosine B. Start with B, finish with B, and these will be A and C. And finally, C squared is equal to A squared plus B squared minus 2AB cosine angle C. And depending on what information you're given, you will decide which of the two is appropriate. Okay? So, let's solve a couple random questions. Now that I've recapped all the major highlights that we have just covered over the last 2 weeks, I'll just put a random question on the board and let's see what we would use to find the answer. Okay, here we go. If I did P, Q, R. If I said this was 10, this was 8, and this was 9. And I say, find, no, let's not even do that. Let's do this. Yes. So if I gave you that information and I say, find the area of triangle PQR, how would we do that? First thing first, is it a right triangle? No. Can we find the height? No. Can we use a half AB sine C? Do we have two sides and the angle between? Or we have two sides, but we don't have the angle between. So we are stuck. Do we have three sides? No, we only have two. Can we find the third side? Maybe, but what we might need to do is we might need to find, say for example, this angle using the law of sines. Once you know angle R, the three angles make a total of 180 degrees. So if you know R and you know P, add the two together and subtract from 180, and that will give you, I suspect this number is not going to work. So let's try a different number here. I think we should try, say, 65. Let's try. This is 10. Let's try 65 degrees. Okay. Right. So let's go ahead and find angle R, and then we can find angle Q. Once we know angle Q, we have the two sides and the angle between. We can use a half RP sine Q. So here we go. We have these two, this pair, and we have this, but we don't have the angle R. So let's go sine of R over 8 is equal to sine of 65 degrees over 10. And when we solve that, we can get angle R. So multiply both sides by 8, we end up with sine of R equal to 8 sine 65 degrees over 10. And therefore, R equal to sine to the minus 1 of whatever we get from this right here. So this is a number. And whatever we get from that number, we do sine to the minus 1, and that will be the angle R. So here we go. Okay, so we do 8 times sine of 65. And that gives us not 7 point, let's go to the guys here. 7.25046 divided by, so it's 0.7250. So therefore, R is approximately equal to, so sine to the minus 1, sine to the minus 1 of 0.72505250 close parentheses equal to 46.47. 46.47 degrees. So now that we know that this is 46.47, which makes sense. This is 65 and this is 10. So this angle has to be less than 65 because this is 8. Okay? So angle Q is going to be equal to 180 degrees minus these two angles here, 65 plus 46.47. So that's going to be equal to 180 minus 0.47, 5 and 6, 11. So it's 111.47 from 180 is going to give us 68.53 degrees. So now we know Q is 68.53 degrees. We are able to now find the area. Area of triangle PQR is going to be a half times 8 times 10. So these are the two sides we're working with. Sine of this angle Q, which is 68.53 degrees. And that's approximately, that's 4 times 10 is 40. So we're talking about 40 times sine of 68, sine 68.53. And that works out to be, this works out to be 37.224, approximately 37.22 square units. So to recap, you were asked to find the area of a triangle that you could not use a half base times height. You did not have all 3 sides, so you could not use Heron's formula. So we're stuck with trying to do some footwork before we can actually find the area. And what we realized is that we had enough information, but if we could get this angle, we could use a half A times 10 sine of Q. So we set about trying to find angle Q, but in order to find angle Q, we had to go through the back door. We had to find angle R first because the law of sines allow us to use this pair along with the 8 to find angle R. Once we know angle R, we know that these two plus this will give us 180. So if this plus this, taken from 180, will automatically give us angle Q. That's what we did. We found R, it was 46.47. We add 46.47 to 65, and then subtract that from 180, we got 68.53. That's our magic number for Q. And then we went in and plug in for Q and sine half AB sine C, and there we go. Or half, in this case, half PR sine Q. And that's what we end up with, 37.22. Okay, we have enough time to work on one more question. Here we go. So let's try 15. Let's try. Okay. 15. Let's call this, say, 40 degrees. Let's call this okay. There you go. Find the area of triangle. Find area of triangle A, B, C. Based on what we have, we cannot do a half base times height. Just based on what we have right there. Actually, we could, but we're not going to do that. I could drop a perpendicular here, and then use this angle, use this, and use opposite over hypotenuse to find the height. But we're not going to do that. We're going to try and use one of the other methods. So, if you notice, we have the 30 and the 40 degrees. So since we know 30 and we know 40, we automatically know angle C. Because 30 and 40 is 70, and therefore angle C has to be 110. So now we have one side and three angles. So in order for us to find the area, we need to get one more side. And of course, we know that we have a pair. We have these two angles, so we could find either side B or we can find side A. It does not matter which one. It will all work out to be fine. So let's do this. Let's find side B. Let's find side B. So B over sine 40 is equal to 15 over sine 110. B over sine 40, B over sine 40 is equal to 15 Okay. Okay, let's go. So, B is equal to 15 sine 40 degrees. Over that. All right. So 15 sine 40 over sine. You see me looking at this because I realize that this is going to give me a negative angle, a negative value. No, I lied, I'm good. So it's equal to 15 sine 40. 15 sine 40 is going to be 15 times sine of 40 degrees is equal to 9.6418 divided by sine of 110. Sine of 110 equal to 10.26. So now we know that this is 10.26. So this is 10.26, this is 15, and we know the angle between. We can use a half BC sine A. Get our answer. So the area will be a half BC sine A. It's equal to a half. What is side B is 10.26. What is side C is 15. And of course, it's sine of the angle between, which is 30 degrees. And that's going to be equal to, well, sine of 30 is a half. But you might not know that, but I know sine of 30 is a half. So it's really, it's 0.5 times 10.26, 10.26 times 15 times sine 30. And that works out to be 38.475. Approximately 38.475. Okay, so we have covered the law of cosines, we have covered Heron's formula, we have covered the law of sines, we have also found the area of a non-right triangle by using a half AB sine C, and of course we know the half base times height, and we have also covered the 6 trigonometric ratios. You have the 3 common trig ratios and their reciprocals. Okay, so we're going to take a break from trigonometry. We're going to go into coordinate geometry, which involves, the x and y axes, equations of a line, equations of a parabola, equations of a circle, and then we'll zero back and come in the back end, take care of some other things. Okay, so come Thursday, our next learning together session, we will look at some simpler stuff, coordinate geometry. Stay tuned. I look forward to seeing you. And on behalf of the Brosis Foundation, which is aimed at providing additional resources to all students wherever you are in the world, on behalf of the Brosis Foundation, we say thank you for tuning in with us. And we hope that you saw some things that piqued your interest, and we look forward to having you visit with us another time. Okay? Have a nice evening.